Welcome everyone. Myself Riya from CSC Data Science Department, pursuing my BE from Sri Venkateswara College of Engineering. Today, I will be giving a presentation on Markov Chain. So, what is Markov Chain? Markov chains, named after Andrew Markov, a stochastic model that depicts a sequence of possible events where prediction or probabilities for the next state are based solely on its previous event state, not the states before. In simple words, the probability that n plus 1th steps will be x depends only on the nth steps, not the complete sequence of steps that comes before n. This property is known as Markov property or memorylessness. History. They were first introduced by Andrew Markov in 1906 as a way to model the behavior of random processes and have since been applied to a wide range of fields including physics, bioeconomics, statistics, machine learning, and computer science. This is a diagram representing two states. Here, the arrow originated from the current state and point to the future state, and the number associated with the arrows indicates the probability of the Markov process changing from one state to another. For instance, if the Markov process is in state E, then the probability it changes to state A is 0.7, while the probability it remains in the same state is 0.3. Similarly, for any process in state A, the probability to change to B state is 0.4, and the probability to remain in the same state is 0.6. Types. Finite Markov chains. These are Markov chains with a finite number of states. Infinite Markov chains. These are Markov chains with an infinite number of states. Discrete time Markov chains. These are Markov chains in which the transition between the states occur at discrete, evenly spaced time intervals. Continuous time Markov chains. These are Markov chains in which the transition between the states occur at random times rather than at discrete ones. Properties. A Markov chain is said to be irreducible if we can go from one state to another in a single or more than one step. A state in Markov chain is said to be periodic if returning to it requires a multiple of some integer larger than 1. The greatest common divisor of all the possible return path lengths will be the period of that state. In a Markov chain is said to be transient if there is a non-probability that the chain will never return to the same state, otherwise it is recurrent. A state in a Markov chain is called absorbing if there is no possible way to leave that state. Absorbing states do not have an outgoing transition from it. Only able to model systems that exhibit the Markov property, which means that the future state of the system is dependent only on the current state and not on the sequence of events that led to the current state. This assumption may no hold for many real-world systems that have memory or hidden variables. They can be computationally intensive, especially for larger systems or systems with many possible states. Markov chains make coverage to a fixed distribution or exhibit periodic behavior with some period d greater than 1. This means that the long-term behavior of the system may not reflect the initial conditions or the variability of the system. The applications are, first, physics. Markovian systems appear extensively in thermodynamics and statistical mechanics, wherever probabilities are used to represent unknown or unmodeled details of the system. Next, chemistry. The growth of copolymers may be modeled using Markov chains based on the reactivity ratios of the monomers that make up the growing polymer chain. The chain's composition may be calculated. Biology. Population dynamics, where Markov chains are in particular a central tool in the theoretical study of matrix population models. Systems biology, for instance, with the modeling of viral infection of single cells. Compartmental models for disease outbreak and epidemic modeling. Few more applications are testing, solar irradiance variability, speech recognition, internet application, statistics, economics and finance, social science, games, and music. Example, here are some examples of Markov chains. The weather can be modeled as a Markov chain where the probability of a sunny day depends only on whether the previous day was sunny or rainy. A simple example of a Markov chain is a random walk on the number line where at each step the position may change by +1, that is to the right, or -1, that is to the left, with probabilities that depend only on the current position. An example of a Markov chain is the eating habits of a person who eats only fruits, vegetables, or meat. The eating habits are governed by the following rules. The person eats only one time in a day. If a person ate fruits today, then tomorrow he will eat vegetables or meat with equal probability. That's all with my presentation. Do like, share, and subscribe.